Hello everyone. This is a new chapter in Module 3. So Module 3, first chapter is about the transformer. Already we have studied in the previous lecture videos. In the domestic wiring, what is domestic wiring? How wiring is made in the domestic purposes or in home, industry, like that. So domestic wiring, we'll be studying how the distribution, how the wirings are made, what is earthing, what is electric shock, and what are the different types of wiring, how different, how bulbs or switches are connected, uh, and what are the different safety devices we'll be studying in this chapter. So here, domestic wiring, the network of wires drawn connecting the meter board to the various energy consuming loads like lamps, fans, motors through control and protective devices for efficient distribution of power is known as electrical wiring. So it covers how different loads or lamps are connected through the protective devices like fuse and CB for the efficient distribution of the power by using wires. How wires are connected. See, all these topics or all these components will be studying in this chapter. So electrical wiring done in residential and commercial buildings to provide power for lights, fans, pumps and other domestic appliances is known as domestic wiring. So electrical wiring is used for provide the power for lights, fans for the domestic appliances is known as domestic wiring. So what are the factors affecting the choice of wiring system? So while selecting the components, what are the things we need to remember? So we should give the long life or durability, safety also we should give, appearance, it should look good appearance, cost should be low, accessibility, maintenance cost, mechanical safety, everything matters or these factors affect the choice of the wiring system. So how the distribution? First initially we need to study how the distribution of the electric energy like uh, to the service means through meter board, how it has connected, distribution board, how to distribute among the different circuits, that distribution. So you might have seen using electric pole, how it has connected to the different domestic appliances, or sorry, the different the sections or different receiver sections. So here, uh, this is the how wirings made from the overhead through the from the pole to the house. So here it has one phase and neutral lines. From the phase and neutral line which is connected to the electric pole, then from the RCC pole it will be connecting through the wires and it will be given to the board, meter board. Through meter board it has connected. How underground cable service? Instead of taking overhead services, overhead wires, that wires, phase and neutral wires, it flows under the ground and which is connected to the meter board. How the meter and distribution boards are connected. So here we can see supply, earth and neutral, earth, phase and neutral, how phase and neutral are connected to the meter, energy meter through fuse. So I think we have seen neutral and phase, single phase lines will be connecting to the meter board through fuse. So fuse is a protective device. Through fuse it will be connected to the line. So in the meter, energy meter, you can see one is directly from the neutral point, one more phase line through fuse it will be connected to the energy meter, and another one earthing it will be connected to the energy meter itself. From the energy meter the lines will be taken, phase and neutral line will be taken to the different sections, neutral and phase, and that will be neutral and phase will be given to the different switches like to the load, fan, lamp, different loads will be connected to the neutral and phase. That is a distribution board. So main energy meter will be given to the main switch. Through mains, from the main switch it will be given to the distribution board. From the distribution it will be connected to the different loads, and earthing also required. So this is the complete how the wirings are made, or how wirings are connected to the different sections like energy meter, main switch and the distribution board in the house. What are the types of wires? Wiring. So there are different types of wiring. So cleat wiring, tough rubber sheet wiring or batten wiring, metal shelter wiring or lead shelter wiring, wooden casing and capping type wiring, conduit wiring. These are the different types of wiring. So here it is used for temporary. Wires are held into the wall and ceiling with the help of porcelain cleats. Screws are provided on the base portion of the cleat for accommodating the wires. After the wire is run through the cleat, cap portion of the cleat is placed over it. This is the something grooves are made for the wires, and the wires are placed in that grooves, and just cap will be placed on the that wooden cleat. This is it wiring. So you might have seen this type of. So something grooves are made. So on that grooves wires are placed, and which is cap also placed on that. Distribution. What are how the wirings are made, what is earthing, what is electric shock, and what are the different types of wiring, how different how bulbs or switches are connected, uh, and what are the different safety devices we'll be studying in this chapter. So here it is a status type of wiring. Wire is carried out in the grooves of a wooden casing. After keeping wires in the wooden casing, it is covered with the wood capping. Easy to install, it will repair. So, but it is accessible, easily accessible, but wires are not exposed to atmosphere. Insulation is less affected by dust, dirt and climate variation, but disadvantage highly inflammable because wood material used for casing and capping is highly inflammable, and wood gets damaged by termites. So this is a casing and capping. Best for domestic and commercial. It provides proper protection to the installation against fire hazards, shock, mechanical damage, dampness. Conduit carrying the insulated wires can be installed on the surface of the walls and ceiling. So here a number of inspection or draw boxes are provided along the run of the conduit in order to inspect the wires. So here within the polymer or pipe, plastic pipe, cables are placed, so it is very safety, and it looks good, and it can be placed inside the wall or just on the top. So this is a conduit wiring. So no risk of fire and good protection against mechanical injury. Earthing and continuity is assured. Waterproof and troubleshooting is easy. Shockproof with proper earthing, durable and maintenance free. But disadvantage are also there. Along with the advantage, very expensive system of wiring requires good skilled workmanship, risk of short circuit under wet conditions due to the condensation of water in tubes. This is about the conduit. So wirings, there are different types we have studied. What is cleat wiring, what is casing and capping, and conduit wiring. But out of all those different types, conduit wiring is best. It is more economical, as well as it is safety against the dust, dirty, mechanical injury, and it even look wise, appearance wise, it is good. Just it can be placed inside the wall, or it can be placed over the wall just by inserting inside the pipe. Next we'll study what are the different lamp, how we can control the lamp? There are two types, two-way control of lamp and three-way control of lamp. Already have studied this type of switching system in basic electrical lab. So one lamp can be controlled by two switches by two-way control of lamp. So this type of switches can be, we have seen in the staircase, in big hall or bedroom, just by switching on or off the single lamp by using the two switches. So here you can observe if the switch S1 and S2 are placed in 1 and 3 or 2 and 4, the lamp is on. But if S1 is at 2 and S3 at 3, then it is a short connection. There is opposite direction it has connected, so it will not on. So two-way control of lamp. This is the truth table. 1 3 and 2 4. The condition of lamp in on state. 1 4 2 3. It is in off state. Three-way control of lamp. One single lamp can be controlled by three switches. You might have seen in the big hall, single switch can be controlled in the different three positions. So here there are two cases, like the middle one, S3, it may be in the straight connection or S3 connected in the cross connection. The first one, S1, S3, S2. Here S3 switch is connected in straight connection. So it's similar to the two-way control of lamp. When S1, S2 in the position 1, 3 and 2, 4, the condition of the lamp in on position. If switch to 1, 4 and 2, 3, then condition of the lamp in off switch, off condition. This is in the straight connection. If it is a cross connection, it's just reverse of the previous one. So if it is 1 and 3, switch is off, lamp is off, 2 and 4, lamp is off, but in other condition, lamp is on. So this is the how it can be, single lamp can be controlled by two switches and three switches. Next we'll see what is earthing, why earthing is required. So you have seen earthing everywhere in our home. Why earthing is required? So something ground potential is required everywhere because it will prevent the electric shock. How it prevents the electric shock? So the important earthing, it can be seen here. So something you can observe here, healthy insulation apparatus not earth. So here insulation is healthy because if you purchase any new appliances, the first starting the insulation is very proper. If earthing is not done also, there is no problem because there is no leakage current flows through the apparatus. So no problem with the starting when the healthy insulation. So supply current flows through the resistance of the apparatus only. So no current flows to the body resistance. The person is safety even if the apparatus is not earth. This is the first case. Second case, if the appliances become older, what will happen? The insulation is now, it is not healthy. It has some defective insulation. Even the apparatus is not earth. What will happen? If the first case and the second case, apparatus is not earth, but first one healthy insulation because the apparatus is new. If it is any problem in the insulation is bad, then the resistance of insulation is zero. The supply current now divides into two part, I apparatus and I body. So that leakage current flows through the apparatus as well as the human body who touches the apparatus. The part of the supply current flows to the body to the ground. The person experiences shock as the apparatus is not earth. So insulation resistance is zero because of the bad insulation. So current flows through the human body. So human body will get shock. Case 3. If the defective, even though the insulation is bad, but if apparatus is earthed properly, what will happen? Instead of flowing, the supply current divides into I apparatus, I body, and one more current path is through earth. So the part of supply current I body flows to the body to the ground, but I body is very less compared to the current flowing through the wire of negligible resistance connecting the apparatus to the ground body, ground. So the person in contact with the apparatus does not experience any shock as the metal casing is earthed. If the earthing is done in each and every home, what will happen? Each and every apparatus will be earthed. So leakage current flows instead of flowing. It flows to the human body, but the amount of current flowing through the body is very less compared to the current flowing towards the ground, because always ground resistance will be kept very low. It's almost equal to 0 because of the very negligible wires of negligible resistance towards the earth. All the current, leakage current flows towards the ground instead of flowing to the ground body. So here the person contact with the part does not experience any shock. That's why earthing is very important. Earthing means the earth resistance, or so the apparatus or resistance of the earth is made near to the ground potential or 0, so that all apparatus person will not get any shock. Apparatus also will be in the safe condition. So there are two types of earthing. One is plate earthing and pipe earthing. So methods of earthing, plate and pipe earthing. We'll see what is plate earthing. So here the plate, it is made up of copper plate. So that copper plate is placed inside the ground, where around the surrounding the ground, that plate, around the plate, the charcoal and salts are placed in the alternate layer, so that it absorbs more current, and it will maintain the low resistance in the ground near to the plate. So here the the earth wire, earthing wire, copper wire for the connection will be placed inside the GI pipe, and it will be connected to the copper plate. So charcoal and salt mixture are placed around the plate, so that it will provide the good moisture content level. It will maintain the moisture level, as well as it will absorb the more current. The next one is pipe earthing. Instead of placing the plate, GI pipe is placed inside the ground, but surrounding the plate there is an alternate layer of charcoal and salts are placed. So it will maintain the moisture level. So if you increase the moisture level of the soil, so it will maintain the resistance of the soil in the low value. So if the resistance is low, more current, leakage current flows towards the ground, so that person who is touching the apparatus will not get any shock. So always earth resistance should be kept as low as possible to maintain the low resistance, to maintain the moisture level in the ground, in the soil. The salt and charcoals are placed in alternate layers, and it will maintain the low resistance. This is an arrangement for pipe earthing. These are very important two topics in the earthing chapter, pipe earthing and plate earthing. If you need to remember the diagram, you have to study properly how to draw the diagram for the earthing. This is how it can be, single lamp can be controlled by 2 switches and 3 switches. Next we will see what is earthing, why earthing is required. So you have seen earthing everywhere in our home. Why earthing is required? So something ground potential is required everywhere because it will provide. So the characteristic of the fused element, one is good conductivity and low melting point. So it will be like rating of the fusing element depends on the rated current and fusing current. So fusing factor means what is the current required to fuse the metal used for the fuse, and rated current how much it can hold the current, maximum current, rated current. So it should have the low melting point and good conductivity. So it is made up of a lead, tin alloy, copper, zinc, lead, tin, aluminum, silver, depending on the what is the smaller current rating of ratings. So you have, I think you have seen it is a small wire placed in the circuit, always is connected in phase wire. When the current, if any short circuit happens or any more large current flowing through the circuit, what will happen? It will melt the wire used in the fuse, so that it will disconnect the load to load side to and source and supply and load side, so that it will not damage any, so it will protect the devices from damaging by a flowing of the high current. So it will not damage any load or any elements connected at the load side. So if it is a heating load, what will happen? It will disconnect, that wires will melt it, and it will just disconnect the supply and load side if any short circuit or any problem in the circuit is. The advantage of fuse: the simplest and cheapest form of protecting device. It requires no maintenance. This can produce a current limiting effect under short circuit condition. With the help of fuse, heavy current can be interrupted without smoke and flame. The minimum operating time is much smaller compared to any other circuit breaker. But the disadvantages of fuse is required to be rewired after its operation. The rewiring requires a lot of time, and it's not possible to provide secondary protection to users. Just if you break the wire, that wire will melt it, and you need to replace the wire again. What is electric shock? So when a person comes in contact with the live wire of electric supply, he gets an electric shock. So maximum current the human body can withstand is about 30 milliampere for a short duration of about 25 milliseconds. So current passing through the body of a person during shock depends on the body resistance. Yeah, and under dry condition, the resistance is very high, 1 to 5 kilo ohm. So here it is used for temporary. Wires are held into the wall and ceiling with the help of porcelain cleats. Screws are provided on the base portion of the cleat for accommodating the wires. After the wire is run through the cleat, cap portion of the cleat is placed. The source of current. So if breathing is stopped, start artificial breathing. Never give anything to drink when the victim is unconscious. Prevention, or what are the things we need to remember? So prevention. So make sure that metallic part of the electric equipment are earthed. Broken switch or plug should be replaced immediately. Before replacing a broken switch, always switch off the supply. Never insert bare wires in the holes of socket for taking connection. Always use well insulated tools. All these points we need to remember during how to prevent electric shock. This is the another type of safety device, MCB, miniature circuit breaker. This is just like fuse. Once the wire which is used for the fuse is melted, again we need to we need to join the new wire. But MCB is not required. If any short circuit or if the current is more crosses the average current, automatically it will be just it will switch off or tripped off. So simple trips off whenever the circuit in the circuit exceeds its rating. It can be switched on again after correcting the fault. So generally it is rated for AC supply of 240 volt 415. So the current rating available is from 0.5 ampere to 63 ampere. A short circuit breaking capacity from 1 kiloampere to 10 kiloampere. So no tripping circuit is necessary. Its operation is very fast, can be reset very quickly after correcting the fault just by switching the button. So this is the MCB here, just by switching on after the correcting the fault. So just trips off the switch when any fault is. It automatically trips off the switch. After the correcting the fault, we need to switch on the switch. That's all.